Hello everyone. So today we'll be discussing one problem of DIT. Right. See, here it is. Compute the 8-point DFT of the sequence. Right. DFT basically FFT is also DFT. We are given a sequence xn with these samples. Right. So this position is x0, x1, x2, x3, x4, x5, x6, and x7. Right. It is a 8-point DFT, so you'll be having only 8 samples. Okay. Now we have to solve this DFT using radix to DIT. All right. So radix to DIT, it's radix is 2, right? This way we write. Okay. So base is 2. So let us start with step number 1. Step number 1 is number of input samples. All right. So to do the solution, we'll follow these steps, right? Which we have already discussed in last class. Okay. So step number 1 is number of input samples. All right, we already know the input samples. Okay, that is 8 because it is 8-point DFT, so input samples are 8. So this can be written equal to 2 to the power m, and from here you can easily get m equal to 3. All right, there is alternative which is mentioned in step number 3. All right, you can find number of butterfly stages, that is m equal to log to the base 2 n, right? This we have discussed in the last class, right? Next is the bit reversal. Okay, you are given bit positions in this order, right? 0, 1, 2 up to 7. Okay, so we'll write binary equivalent of this, right? And then reverse the bits. Okay, after reversal, we need to index these bits. Okay, so bit reversal index will be of this form. Okay, so we get these sample positions 0, 4, 2, 6, 1, 5, 3, 7. Okay, that means we'll pair 0, 4, 2, 6 will get pair, 1, 5 will get pair, and 3, 7 will get pair. So next task is to place these in your butterfly diagram. All right, these are basically my input samples. All right, so like we have placed in here. Okay, and the output was 0, 4. After bit reversal, we were getting 0, 4, 2, 6, 1, 5, and 3, 7. Then we can find out number of butterflies in each stage, right? N is 8, so 8 by 2 is. Next is stage number 5, separation between inputs and outputs of each stage. All right, we can determine using this formula. Okay, so this comes out to be 1 for stage 1, right? 2 for stage 2, and 4 for stage 3. All right, uh, small m is the stage index, right? It can take values 1, 2, and 3 because it's an endpoint DFT, so it can go up to 3. Next is Twiddle factor exponent. Okay, Twiddle factor exponent, we can write Twiddle factor like this. Okay, so this k will be determining, right? So how many values of k will find out, that is dependent on the values we got in stage number 5. All right, like for stage number 1, we'll have only one value of Twiddle factor, the exponent of Twiddle factor. Okay, now this is the formula. Okay, so n is that is number of stages, and small m is the index. Okay, for stage 1, the small m is 1. All right, and n is always 8. Okay, now I'll vary t. Okay, now for stage number 1, as we can have only one value, so we'll consider for t equal to 0. Okay, so you can substitute and get this value. Likewise, for stage number 2, it can take only two values, right? You can have two exponents, two Twiddle factor exponents, right? Likewise, for stage number 3, you'll have 4 Twiddle factor exponents. Okay, see, we have calculated for stage 2 and stage 3, right? Stage 2, it have 2 Twiddle factor exponents, right? For t equal to 0 and 1. Likewise, for stage 3, we have for t equal to 0, 1, 2, 3, and we get this thing. Okay, 4 Twiddle factor values, Twiddle factor exponent values. Okay, now from this particular step, you can easily determine how many Twiddle factors will be using in our butterfly diagrams, right? See, we have 0 with exponent 0, 1, 2, and 3. Up to 3 maximum we can have in our butterfly diagram, right? So we can write those like w8 to the power 0, right? w8 to the power 1, okay, w8 to the power 2, and w8 to the power 3. Okay, next thing is we need to determine their repetition factor, that how many times one Twiddle factor is going to repeat or exponent is going to repeat. Okay, So as per step number 7, we know this is the relation to the power capital M minus M. Capital M, we know it's 3, right, and small m is the index of stages 1, 2 and 3, right. 3 stages there are which can be used to substitute M. Okay, so we get stage 1 equal to 4, means 4 times my Twiddle factor will be repeating. Okay, and which Twiddle factor will repeat? That is 2 W8 to the power 0. All right, that is for 0, t equal to 0. Okay, so that is the first one. All right, then for stage 2 it will repeat 2 times. Okay, so how many Twiddle factors we have for stage 2? We get this idea from here, right? This is 0 and 2. Okay, that means this will be there and this Twiddle factor also will be there. Okay, so each of them will be repeating twice. Okay, so there will be 2 instances of these two. Okay, likewise for stage 3 each Twiddle factor will repeat only there will be no repetition at all. All right, there will be no repetition at all. There will be on one instance of each Twiddle factor, right? 0, 1, 2, 3, all the Twiddle factors are considered in stage number 3. Okay, now this is the general structure of butterfly diagram, right? If we have 2 inputs, right, 2 samples, okay, then this Twiddle factor will be placed on the lower side. Always it will get multiplied with second sample in the pair. All right, and obviously we've already calculated this thing in DIT lecture number 1. Okay, so this side it will get, your A will get multiplied with 1 and B will get multiplied with this Twiddle factor and minus 1. Okay, so up to here this will result A only, and this will result minus of Twiddle factor multiply B. Okay, at this point, or obviously at this point, right? At this point, this value, right, A, and the value coming from this side or this side will get added up. Okay, so this will get added up with A, so results A minus this thing. Okay, and likewise this side, this will result A plus, you will be multiplying with plus 1, so this will become plus because this is positive till this point. Okay, B multiply W and K, right, at this point we are having, so we can add this value to A. Okay, so I think that is clear. This will be followed for all the butterflies, right? So let's see our butterfly diagram. As you can see, all the Twiddle factors are well placed, right, on the negative side of the on the lower side of the sample pair, right? This is one pair 0, 4, so it is getting multiplied with second sample only, right? Likewise in this pair it will get multiplied with 6, likewise in this pair it will get multiplied with 5. Okay, and in this pair 3 and 7 pair it will get multiplied with 7. Okay, likewise for stage 2. Okay, stage 1, these two samples are the upper samples. Okay, and for this butterfly, if you consider, so see, for this butterfly, if you consider, this is the first sample and this is second sample. All right, not this one, this one. Okay, so your Twiddle factor will get multiplied with this sample only. Okay, okay, it will be available on this point only, right? Likewise for butterfly 2 in this segment, we have this. All right, so your Twiddle factor will multiply with this side. Okay, and following the same rule, you have to place all the Twiddle factors like that. Okay, on the lower samples, right? And obviously your upper sample will get multiplied with 1 and lower sample it is with minus 1, right? So you have to write 1 and minus 1, right, this way. Now you know that your values, intermediate values and even the final values what you get will contain some Twiddle factor component, right? Therefore we need to find out Twiddle factor values first. All right, now we know from step number 6 that there are only 4 Twiddle factors we need to calculate, right? W8 to the power 0, W8 to the power 1, W8 to the power 2, and obviously W8 to the power 3, right? So let us calculate one by one. Your Twiddle factor is generally represented by some exponential of minus iota 2 pi by n, right? 2 pi by n, but this time we have its power to be equal to 0. Okay, so this factor will become 0 and it will result this Twiddle factor to be equal to 1. Okay, now let us find out second one. Right, this time e to the power minus iota 2 pi divide by n, and its power is 1. Okay, so we can expand this one by Euler's identity. Right, so it will become cos of 2 pi by n, n you know it is 8. All right, minus iota sine 2 pi by 8. All right, n is 8. Okay, so 2 4 j 8, likewise 2 4 j 8, so this will become cos pi by 4 and sin pi by 4. Okay, so your value comes out to be 0.707 minus iota 0.707. all right, now Twiddle factor to the power 2 will become equal to e to the power minus iota 2 pi over n to the power 2. all right, so let's replace this n with 8. Okay, so 2 to the 4 4 to the 8. Okay, so your equation will become cos of pi by 2 minus iota sine pi by 2. Right, so cos pi by 2 is 0. Right, minus iota and sine pi by 2 is 1. all right, so this is minus iota. Okay, and finally the fourth one, e to the power minus iota 2 pi by 8 to the power 3. all right, 3 to just 6 or 2 4 ja 8, we can cancel it out. Okay, so 3 pi by 4. Okay, so cos 3 pi by 4 minus iota sine 3 pi by 4, it will result negative values. Okay, equal to minus 0.707. all right, and this is minus iota 0.707. all right, now as we know the value of Twiddle factors, right, so I'll first calculate for stage 1. Okay, now for stage 1 we are having these as my inputs. Okay, these are in bit reversed order. all right, and I have marked these outputs of butterflies as S1 naught to S17. Okay, so let's find out what my S1 naught is. On upper side of butterfly, my first sample in the pair, that is 0.5, will get added up with the second sample multiplied with Twiddle factor. all right, so Twiddle factor multiply with, what is my second sample? 0. Okay, so S1 naught will be 0.5 only. Okay, likewise you can calculate for S1 1, right, this place it is 0.5 minus, because minus 1 is getting multiplied with this, minus this Twiddle factor, and obviously again this is getting multiplied with 0, so it will result 0.5 only. Okay, likewise you can calculate for all the other samples for S2, S13, S14, right. Now these elements, these S1 to S7, they will act as inputs to stage 2 butterflies. all right, and in similar way like we have calculated for stage 1, we'll calculate for stage 2, right. Now let us do the calculations for butterfly 1 of stage 2. all right, its upper sample is S10, right, and another sample is S12. These two are going to be paired, right. Now let us mark this point as S2, stage 2, 0th sample, right. So this will become equal to, see, first sample of this first input S10, and it will add with this sample, right, multiplied with this Twiddle factor. all right, so W8 to the power 0 and S12. Now substitute values for S10, W8 and S12, right, it is 0.5. okay, we know. Likewise W80 is 1, we have already calculated, and S12 is 0.5. okay, so this becomes equal to 1. all right, so our first sample is 1. Likewise this sample will be same values, just a change of sign in between. okay, so this will become 0.5 minus 1 multiply with 0.5. okay, so 0.5 cancel outs and you're left with 0 only. okay, so this way we can calculate for all the butterfly values okay, for stage 2. Okay, in similar way we can find out the values for second butterfly, right? It will come out to be 0.5 minus iota 0.5. Okay, at this point S11 and S13 are the inputs, okay, input pair, and twiddle factor here is W82. So this equation becomes S11 plus twiddle factor multiply with S13. All right, now I know the values, we know the values of S11, that is 0.5. okay, twiddle factor we have already calculated, okay, that is minus of iota. All right, so I'll write minus of iota multiply with S13 is again 0.5. okay, so this value is nothing but the value I've written over here, right? In this way you can calculate for other values of other two butterflies of this stage, right? Check the inputs carefully, right? Like for butterfly 3 the inputs are S14 and S16. All right, likewise for butterfly 4 the inputs are S15 and S17. All right, and for butterfly 3 the twiddle factor is same as was for butterfly 1, okay, and for butterfly 4 it is the same twiddle factor which we have multiplied in the second butterfly, okay, as we have calculated all the values for stage 2, right? So now these values will act as inputs to stage 3. All right, now if we consider first butterfly of stage 3, its input will be this one, right? That is value 1, okay, and second input will be again 1, okay, and the twiddle factor here is W8 to the power 0. All right, so if I directly perform this thing, it will be equal to 1 plus what is the value of W8 to the power 0? That is 1, and the second input is also 1, right? So that is 2 nothing. Now second output of this butterfly is X4. All right, and you know inputs are same, okay, because we are considering the same butterfly number 1. So first element is 1 only, and this time we'll write minus, okay, because my second element will multiply with minus 1, okay, so minus twiddle factor is same W8 0, okay, and multiply with 1, okay, this value, and we know W8 0 is 1 only, right? So 1 multiply 1 is 1, okay, so this will lead to 0, okay. Okay, this way you can calculate for all the other samples, right? Like for X1 it will be, see the inputs for this butterfly we have considered the second one. So first input is, here it is 0.5 minus iota 0.5, right? And second input is 0.5 plus iota 0.5. all right, and twiddle factor we have to consider is W8 to the power 1, okay. So we can write input 1 plus, right, input 1 is 0.5 minus iota 0.5 plus this is the value of twiddle factor W8 to the power 1, right, and multiplied with second input, right, 0.5 plus iota 0.5, okay, and this will lead to this result. All right, likewise we can find out for this one, right, for this one, right, and the second output of this butterfly is, I mean the second butterfly is 0.5 plus iota 0.207. It is calculated using same input values and twiddle factor value, right? Only difference is that we have changed the sign, okay. Same way you can calculate all the other values, right? These values, these x0 to x7, these are all DFTs, right? Now thus the final transform value will become xk equals sample number 1 is 2, right? You can see sample number 1 is 2. all right, second is 0.5 minus iota 1.2, second is 0.5 minus iota 1.207, third sample is 0, right? Fourth one is 0.5 minus iota 0 0.207, right? Okay, this is the fourth sample, right? Now fifth one is 0 again. Okay, then sixth one is 0.5 plus iota 0.207. Then again we have 0, right? And final sample we have 0.5 plus iota 1.207. This is your DFT calculated using radix to DIT algorithm, right? That's all for now. Thank you.